Hey seniors, today we're going to continue with constant rate of changes, and today we're going to compare tables and graphs. Yesterday we did graphs and equations, today tables and graphs. So let's go ahead and jump in. On your notes page, go ahead and draw your line. In the top left-hand corner, go ahead and write comparing tables and graphs. So let's talk again about what constant rate of change is. When I'm talking about constant rate of change, or if I'm saying greater rate of change, I'm always talking about the slope. No matter if it's a graph, a table, an equation, I'm always talking about slope. My initial value is always going to be my y-intercept. I want you to write both of those things in your notes page. I know it's like the fourth time, and Shavance is probably like, oh my gosh, Miss Abel, this is boring. I don't want to write this again. Write it again. I don't care. All right, so when comparing tables and graphs, find the slope to compare which one has the greater rate of change. So we're interested in which one has the larger slope, which will tell me that that has a larger, greater rate of change. Let's go ahead and jump into an example. All right, so there's a lot of things going on here. I have graphs, I have tables, I have a scenario. All right, but what we're interested in is, again, working with our table and our graph. All right, so I'm going to go ahead and read the scenario to you. Candace is emptying a bath basin after soaking her laundry. The amount of water in the basin can be represented by the table above. Determine whether the following graphs represent this situation and justify your answer interpreting the rate of change and initial value from each graph. So again, I'm looking for rate of change and the initial value. And what I want to figure out is which one of the graphs represents the table. So what I need to figure out is, first of all, what my initial value is. So minutes is going to be my x value. Liters of water is going to be my y value. So, and that's represented on the graph here, on each of these graphs. Time is on my x-axis, and water is on my y-axis. So the first thing I'm going to look for is my initial value. Again, my initial value is where x is 0. So if I have the coordinate 0, 20, x is 0 here, and that means that I have 20 liters of water. Now, I can look at this table and see that as time passes on, my amount of liters is decreasing. So I know that I'm going to have a negative slope. What that tells me is that I can immediately eliminate two answer choices that don't have a negative slope. I can eliminate answer choice C because my line is increasing. I know my slope is negative, so I need to find one that need to find a graph that has a line that's decreasing. A also has a line that's increasing, so I know that that's not going to be correct. That leaves me with B and D. Well, D does have an initial value of 20, and so does choice B. However, if I'm looking for the graph that represents the table, again, I see that for every 2 minutes, my liters of water left over in a tub are decreasing by 4. And again, if I want to find the slope of a line, I can go ahead and do change in y over change in x. So 16 minus 20 over 2 minus 0. 16 minus 20 is going to leave me with negative 4, and 2 minus 0 is just going to leave me with 2. Now, negative 4 divided by 2 is going to leave me with negative 2. So again, I'm looking for the graph where it's decreasing every single time. So I can go ahead and actually eliminate answer choice D because my line is just going, if I were to write this equation, it would be y just equals 20. And this shows a constant rate of water remaining as time goes on. But I know per the table that my amount is decreasing. So that's going to leave me with answer choice B, which makes sense because I have an initial value of 20, which is where my y-intercept is, and my line is decreasing. For every 2 minutes, I'm losing 4 liters of water. All right, let's do another one. All right, for this one, I have a graph and I have a table, and I need to figure out which one has the greater rate of change. So I'm going to work just with my table first and then my graph. So what I need to do is figure out my slope of my table. And again, of course, when I'm finding slope, I'm interested in change in y over change in x. So I'm going to take my first two values from my y column, and I'm going to go ahead and subtract them. So if I have -3 minus -10, be very careful there, and then I'm going to take my change in x, which is -3 minus -6. And again, I just got those. I got my top numbers from my first two values of the y side of my table, and my bottom numbers from the first two values of my x value side of the table. So then all I have to do is solve this. -3 minus -10, keep change, it's just going to leave me with 7. And then -3 minus -6, keep change, it's just going to leave me with 3. So I have a slope for my table of 7/3. Don't freak out about the fraction yet, because it's actually super simple to compare. Now I need to figure out the slope of my line to determine which one has the greater rate of change. And so what I can do for that is start with my y-intercept and just find the slope of the line between two clear points. So I see that my line crosses the graph at 3. My next clear point comes at 1 and 0. So again, all I have to do now is find the slope of the line between these 2 points. I see that my line is increasing, so I know that my slope is going to be positive. So now I just need to figure out my rise and my run. So if I look at my graph, I see that I rise 1, 2, 3 times, and I run 1 time. So my slope of this graph is just going to be 3, because 3 divided by 1 leaves me with 3. So now what I have to do is figure out which one has the greater rate of change. Is it my table or is it my graph? My graph has a slope of 3. My table has a slope of 7/3. It's really hard to compare whole numbers and fractions. The best way to do it is to turn this fraction to a decimal. So let's do that. If I have 7/3, the way I turn it into a decimal is top goes in, bottom goes out. 3 goes into 7 2 times. 2 times 3 is 6. If I subtract 7 minus 6, leaves me with 1. 3 doesn't go into 1, so I know I have to put a decimal, but then I can drop down to 10. 3 goes into 10 3 times. 3 times 3 is 9. That's going to leave me with 1. If I bring down another 0, 3 goes into 10 3 times. So I'm going to have, this table has a rough slope of 7/3 or 2.3 repeating. Now, which one has the greater rate of change? Well, I'm comparing 2.33 repeating and my graph, which has a slope of 3. And I see that 3 is the larger number. It has the greater rate of change because it's increasing by a larger amount each time. So my graph has a greater rate of change. And that's literally it, guys. So, all right, that's going to be it for me. Remember, when you are comparing tables and graphs, figure out what your slope is and compare it from there. That's going to be it for me. Let's go ahead and practice.